Welcome to my channel. In this lecture, I am going to discuss about another type of machine learning algorithm is naive Bayes algorithm. The first point I already told you in the previous lecture. First, we have to identify the type of that machine learning. Naive Bayes algorithm is a type of supervised machine learning algorithm. That's the first one. And the second point is it is used for solving both the classification problems and regression problems. Supervised machine learning means to build a model using naive-Bayes algorithm, the dataset must be a labeled data. That means the dataset must contain a class label. And mainly the most important of naive-Bayes algorithm is the naive-Bayes algorithm is works based on Bayes theorem. Okay, by using that Bayes theorem only, we are building a model of naive-Bayes algorithm. Here, one more keyword you have to remember is why we are called as naive of naive-Bayes algorithm. Why? Because in naive-Bayes algorithm, what are the features we are having in the data set? All the features are independent of each other. All the features are independent of each other. That's why we are use the word navy in naive-Bayes algorithm. And another one is naive-Bayes algorithm in general performs well mainly for text classification. That means either for spam filtering or sentiment analysis and categorical data predictions. In these problems, mainly we are using the naive-Bayes algorithm. Okay. Next, we will see what is the Bayes theorem. I already told naive-Bayes algorithm works based on which one? Bayes theorem. Okay. So that Bayes theorem we are also called as posterior probability. Okay, so the Bayes theorem is the foundation of naive Bayes. The Bayes theorem can be expressed with a formula called as posterior probability. So posterior probability is P of C by X equals to P of X by C into P of C by P of X, where P of C by X is a posterior probability, P of X by C is called as likelihood probability, P of C is class prior probability, P of X is the predictor prior probability. Predictor means to which instance we have to find the class. That instance we are called as a predictor prior probability. Okay. So here what is meaning of P of C by X? That means P of C by X means what is the probability for occurring a class C to the given feature X or to the given instance X. Okay, that is P of C by X. P of C by X means what is the probability for a class C to the given X. And P of X by C is called as likelihood probability. What is the probability for occurring X to the given class C? Here the class may be a binary class or it may be a multi-class class label. Okay, that is P of X by C. That is what is the probability for occurring X to the given class C. P of C is called as prior probability. What is the probability for occurring a particular class from the entire data set? Later, next slide, we know clearly about what is meaning of P of C, P of X, X by C, and P of C by X. Okay, what for example, if our data set contains 14 records. Okay, in that 14 records, for example, we're having the 5 no records and let us assume 9 are S records. So what is the probability for no class? The probability for no class is how many no class records we are having? 5 records. That's why the probability for class no is P of no equal to 5 by total records are 14. That is P of probability for no. Likewise, we have to finding the probability for S also. Probability for S means 9 by 14. That is called as P of C. And P of X is the evidence or a marginal likelihood probability. That is, what is the probability for observing the X, or what is the probability for occurring the particular feature, okay, or particular test instance. Okay, this is four terms you have to remember, okay, before applying the naive Bayes algorithm. Okay, now we will discuss how this naive Bayes algorithm works and how we are predict the class of the given test instance by using the naive Bayes algorithm. So to find out the class of the given test instance, here I am choosing a weather dataset. Okay, a weather dataset here I am using to predict whether to play a tennis or not by using the features, that is outlook, temperature, humidity, wind. By taking the values of these four features, we have to predict, okay, whether there is a chance to play tennis or not. That is the main aim of this problem. Clear? So I already told this naive Bayes algorithm mainly works based on which one? Posterior probability. Okay, so in this problem, how we are calculating the posterior probability is, it can be calculated. First, we have to calculate the frequency table for each attribute against the target variable. Here, target variable means class label. First, we have to finding the frequency table to each feature against the class label, then transforming this frequency table into likelihood table. Then finally we use naive-Bayesian equation to calculate the posterior probability. That means first we have to find the frequency table, then transforming the frequency table into likelihood table. Then we have to apply the naive-Bayes equation to calculate the posterior probability for each class. That means, let us assume if we are having our data set contains how many classes? Two classes. For example, one class is S, another class is no. We are calculating the posterior probability for S class and we are calculating the posterior probability for no class. From these three classes, from these two probabilities, which probability have more value, okay, that is the class of the given test instance. That is the meaning of this one. The class with highest positive probability is outcome of prediction. That means the class of highest positive probability is the class of the given test instance. Okay, that is the procedure to find the class of the given test instance. Okay, so now what first step is, first we have to calculate the prior probabilities from the given data set. The prior probability, what is the class label here? Play golf, okay, or some play tennis. Here we are having two classes, some records are no class and some records are S class. That means it is a two class problem, binary class problem. So what is total having how many records? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That means totally we are having 14 records. Okay, so from 14 records, what is the probability for S? Means how many S records were contained? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. We are having the 9 S records. That's why 9 by 14 is the probability of S, prior probability of this one. Which one? S. And likewise, we have to find out the probability for no class. So, no class is 1, 2, 3, 4, and 5. We have 5 records with no class. That's why 5 by 14 is the probability for no. Okay, clear. That's the first step. The second step is calculating the likelihoods for each class. So remember, S class is how many records? 9 records. No class contains how many records? 5 records. Keep in mind. Okay, remember these values. S class 9 records. No class 5 records. Clear? By using this one, next we have to calculate likelihood probabilities. To calculate likelihood probabilities, we have to first find out the which one? Frequency table. Let's see how we are find out the frequency table. So to find out the frequency table to each feature in the data set, first we have to write down the features. What are the first feature? Outlook. Okay, so what are the values of the outlook features? Rainy, overcast and sunny. That means the outlook feature contains three different values. That is sunny, outlook, overcast and rainy. Then we have to find out how many records we are having outlook equal to sunny and play golf equal to S. Okay, so outlook equals sunny and play golf equal to S. That means the class variable is S and outlook equals sunny. Let's see how many we are having. Sunny S is one record, sunny S is another record 2, and again sunny S is another record. We are having 3 S records with outlook equals sunny. Likewise, outlook equals sunny with no records. Outlook equals sunny, no one record. Outlook equal to sunny, no another record. That is 2 no records with outlook equal to sunny and play golf equal to no. Likewise, outlook equal to overcast with play golf equal to S. Let's see how many records we are having. Overcast S1, overcast S2 and overcast S3, overcast S4, 4 records. That's why giving us 4 here. Clear? And overcast equal to no records. We are having only 4 overcast records, all are S records. That's why no class records are 0. Likewise, outlook equal rainy with S class. Okay, outlook equal rainy S, rainy no 1, rainy no 2, rainy no 3. Okay, that's it. So rainy with no class is 3 records and rainy with S. This is rainy with S 1 record and rainy with S is another records. So 2 records with rainy with S. Likewise, we have to find out the frequency table to all the features. Once if you are finding the frequency table, then we are find out the likelihood table by using this frequency table. So how we are find likelihood table means outlook equals sunny with play golf equal to S. We are having the 3 records. Total S records how many? 9. Okay, that's why the likelihood probability for outlook equals sunny for S class is how much? 3 by 9. Okay, and outlook equal to overcast with S, that is 4 by 9. Here 9 means total S records. We are having total S records how many? 9. Outlook equal rainy. Okay, 2 with S and total are 9. 2 by 9. Likewise, we are having the 5 no records. That's why outlook equal to sunny with no 2 records and no class is 5 records. That's why 2 by 5, 0 by 5 and 3 by 5. Simply we are finding the frequency table. The frequency table is converted into likelihood table. To each and every value of the frequency table, we have to maintain with the number of records with S class or number of records with no class. So similar way we are finding the frequency table for humidity. The humidity contains two values, high and normal. Again high with no and high with yes. Again humidity with normal. How many records we are having? Humidity with normal, again S records. Humidity with normal, again no records. Likewise we have to find the frequency table and likelihood table. So outlook, humidity, and next feature is temperature. Again temperature contains three values, hot, mild and cool. So similar way we are finding temperature equal to hot with S records are 2. Let's see, hot S 1, okay, hot S 2, likewise 2. Again temperature equal to hot with no, hot no 1, temperature equal to hot no 2, that's it, that's why 2. Likewise we are finding the frequency table of temperature, and that will be converted into likelihood table by simply maintaining the total number of S records and total number of no records. So likewise we are finding the frequency table to the given data set, then convert into that frequency table into likelihood table. Now after finding the frequency table, then we have to find, okay, what is the class of the given test instance. For example, here if I'm taking the instance outlook equal to rainy, temperature equal to cool, humidity equal to high, wind equal to true. We have to find out what is the class of this test instance X. Now what we have to do? We are finding the probability, positive probability for S class to the given X, and again we are finding the positive probability of no class to the given X. Okay, so by after calculating the positive probability for S class and no class, which probability having the more value, that is the class of the given test instance. So now how to calculating the positive probability for S to the given X means, so P of what are the values or the given test instance outlook equal to rainy, that means probability likelihood probability of rainy by S into, okay, temperature equal to cool by S value into humidity equal to high by S into wind equal to probability of wind equal to true by S equal to probability of S class, that is prior probability. Okay, so probability of S given X equal to this entire thing is called as likelihood probabilities. Okay, this is called as prior probability. Okay, so here we no need to maintain the what is called as denominator probability, that is called P of X. Why? Because for the both S class and no class the P of X value is same. That's why simply we no need to uh, take the value of P of capital X. Simply we have to find out P of X by C. Okay, what is the formula for positive probability? Actually P of C by X equals to, okay, P of X by C. It is which one? Likelihood probability into prior probability. It is called P of C. This may be S class or no class. Then entire thing we have to divide with P of X. Here the P of X is, okay, have the same value either for S class and either for no class. That's why it's not impact on the overall probability value. That's why simply we ignore this one. That means simply we are finding probability of likelihood and the prior probability for P of C. Okay, that's means this is the likelihood probability and this is the prior probability. Now let's see P of S by X. So now from the likelihood table, rainy with S you can see the value. Rainy, go to the outlook equal to rainy, okay, with, so outlook equal to rainy with, yes, we have how many records? 2. That's why here we will write 2 by 9. And temperature equal to cool with which one? Yes, go to temperature likelihood table. Okay, temperature likelihood table with cool, yes, we're having 3 by 9 value. Okay, that's why into 3 by 9. Next, humidity equal to I. What is the probability for humidity equal to I to the given S? Okay, so humidity, go to humidity frequency table. Humidity equal to high with, yes, we're having the likelihood probability is how much? 3 by 9. So we are writing as 3 by 9. Next, wind equal to true by S. Go to windy frequency table. Okay, windy with what's called as true. Okay, true. Okay, true with, yes, contains the likely probability is how much? 3 by 9. So here writing as 3 by 9. And probability of S. What is the probability of S? First step we are finding the probability of S and probability of no. Probability of S is 9 by 40. Probability of no is 5 by 14. So here I am finding the positive probability for S class. That's why the probability for S class is 9 by 14. So if you calculate this entire values, then you will get in the final value 0.005. Similar way, we are finding the posterior probability for no class to the given X. So what is the likely probability for rainy to the no? What is the likely probability for cool to the given no? What is the likely probability for high to the given no? Likewise, we have to take the values. For example, rainy by no. Go to the outlook. Rainy by no. We are having the 3 by 5. Okay, that's why here writing as 3 by 5. Cool by no of temperature. Go to temperature. Cool by no. That is 1 by 5 is the likelihood probability. That's why here writing as 1 by 5. Similar way, high by no, true by no, and prior probability of which one? No class, 5 by 14. If you're solving this entire thing, we're getting as which one? How much? 0.02. So if this is the probability, positive probability of S class, this is the positive probability of no class. From these values, probability of no, the positive probability of no to the given X is greater than, okay, the positive probability of S to given X is greater. That's why the given test instance belongs to which class? No class. Why? Because the no class probability is more compared to the S class. That's why the given test instance X belongs to no class. That is simple algorithm, okay, for finding the class of the given test instance using the posterior probability. Okay. Next thing is, we can see what are the advantages of naive-Bayes algorithm. The first thing is it is simple and easy to implement and fast and efficient. It may also works with high dimensional data. It handles categorical data as well. It's not only for handle the continuous values, it will also handle the either binary attributes, nominal attributes, or ordinal data also it handles very well. And it requires less training data. It performs well with multiple classes. For example, in the given example, we take only two classes, S class and no class. That is a binary class problem. Even though if you are having more than two class also, it performs well. It again performs well even with the irrelevant features. Why? Because sometimes maybe some features may not be relevant to another feature. Okay, even if you're having irrelevant features in the data set, the algorithm works very well. Okay, and robust to missing data, this is one more advantage. So even though if you're having the missing data in our data set, it works well. Why? Because if you're having the missing data, then obviously when we are finding the likelihood probabilities, obviously the likelihood probability values may be decreasing, or that will impacting on in number of classes. That's why it works very well even though if you're having the missing data in the data set. Those are the advantages of naive Bayes. And drawbacks of naive Bayes algorithmic: strong independence assumption. That means it is also called as navy. That means each feature is taken as independent of each other. Okay, that is one of the drawback of naive Bayes algorithm. So independent of each other. Okay, which is really true in real world dataset. If features are highly correlated, the algorithm performance can suffer. For example, if you're having for example, all the irrelevant features or independent features, then it works fine. If you're having any some relevant features in our dataset, that time it does not works very well. Okay. Next, zero probability problem. What does it mean? If any feature probability of the given class may be either S or no is 0, the entire positive probability of S or no class becomes which one? 0. Clear? That is main problem with naive Bayes algorithm. That may also handle by using the Laplace smoothing. That means let's see one more time. For example, here we can see overcast equal to positive probability, likelihood probability for overcast with noise open check records 0. If you are given the test instance something outlook equal to overcast or something humidity some value and temperature wind, but outlook positive probability for outlook equal to no is having 0. That means that entire test instance of no probability becomes which one? 0. Okay, that is the main problem with naive Bayes algorithm. Naive Bayes zero probability problem means if any feature probability to the corresponding x becomes 0, then the entire test instance probability becomes 0. Okay, and it is not suitable for continuous data without discretization. Okay, discretization means if you're splitting the data into some number of the bins. For example, if taken as A's column. Okay, so the A's column having the values, different continuous values, for example 10, 20, 30, 40, 50, like this, we're having the values. So likewise, if you take consider like this, we not get the good performance in naive Bayes algorithm. What we have to do is we have to convert this A's column into some discretization. That means we have to split into some number of bins. That A's column we divide into less than A's 10, less than A's, uh, for example 10 to maybe some 30, greater than 30, like this we have to find, dividing the particular feature into number of the bins by converting that bins, by converting the continuous feature into discretization. When we are applying the, then only we need to applying the, we have to applying the naive Bayes algorithm. Okay, next one is limited expressiveness and sensitivity to which one, skewed data. Sensitivity which one, skewed data. That means if the data set is unbalanced, that set is unbalanced, okay, then neighbors can be biased towards that majority class only. For example, if you have the 14 records, out of 14 records 12 records may be S class, 2 records one no class, then majority of the classes having the S class. That's why there may be more chance any given test instance belongs to the S class. Why? Because majority we are having the S class records. That is one of the drawback of which one, naive Bayes. That is skewed data. If you are having the more number of particular class records, obviously there may be more chance to the given test instance belongs to that class only, and it having the poor performance on highly complex problems. Okay, so these are some of the advantages and drawbacks of naive Bayes algorithm. Thank you.